Good afternoon, dear participants. We are pleased to present the results of our research on structural and functional model of formation of STEM competencies of students of professional higher education institutions in mathematics teaching. The relevance of the study is due to the rapid development of STEM education, changes in economic activity, its technical base and organizational forms, conditions and requirements that it puts forward to the level of knowledge and qualifications of professional junior bachelors. The purpose of the study was to theoretically substantiate, develop, and experimentally test the effectiveness of the structural and functional model of STEM competencies formation of students of professional higher education institutions in teaching mathematics. The purpose of this article is to highlight the features of the developed structural and functional model and the effectiveness of its implementation, in particular using the educational and methodological support developed by the authors. The analysis of scientific sources and pedagogical experience has shown that in modern educational practice there are contradictions between a significant amount of accumulated domestic and foreign experience in the organization of STEM education in secondary education institutions and insufficient understanding of the need and relevance of STEM education for professional junior bachelors, requirement for the level of STEM competencies of graduates of professional higher education institutions and the existing degree of their formation, the need to introduce innovations caused by the processes of digitalization and European integration, and the insufficient speed of updating curricula and methodological support for professional junior bachelors. The main idea of STEM education is the practical preparation of students to solve certain real-life problems by integrating STEM disciplines: science, technology, engineering, and mathematics. Mathematics is one of the STEM disciplines on the basis of which other academic disciplines can be integrated, which contributes to the development of STEM competencies by bringing classroom learning closer to real-world problems through practical research. In accordance with the analysis of the state of implementation of STEM education in the scientific and pedagogical literature and educational practice, the content of STEM competencies of students of professional higher education institutions is specified. STEM competencies of students are defined as an integrated personal formation manifesting itself in the developing of its components: mathematical competence, information and communication competence, basic competence in the fields of natural science and technology, project and technological competence, and soft skills, including critical thinking. We have identified 4 criteria for assessing students' STEM competences in mathematics: value and motivational component, creative and active component, cognitive component, and reflective and evaluative components. These criteria make it possible to pedagogically monitor the state of formation of students' STEM competencies at elementary, intermediate, sufficient, and high levels. The developed structural functional model consists of external factors in 4 blocks, which we will discuss in more detail. 3 groups of external factors have been identified that influence the actualization of STEM education. These are social order for the training of highly qualified STEM specialists, the methodological block, which includes the principles of education and the main approaches to organizing education, modernization of technologies, and teaching methods. Development of ICT and STEM technologies, including the development of special and adapted learning tools, including for learning mathematics. Structure of the model for the formation of STEM competences of students of institutions of professional higher education in mathematics consists of target, content, activity, and diagnostic blocks. The target block defines the goal. The content block reflects the content of students' STEM competencies. The pedagogical conditions for the formation of STEM competences of students of institutions of professional higher education in mathematics include motivating and stimulating students to educational, cognitive, and research activities in teaching mathematics through engagement in cooperation and the use of individual and group coaching. Implementation of STEM projects in mathematics education, Application of ICT to provide visibility and research orientation of mathematics teaching. The activity block also includes the technology of forming students' STEM competencies, methods, means, and forms. The diagnostic block presents diagnostic tools based on the developed criteria: value motivational, creative and active, cognitive and reflective evaluative, and indicators of students' STEM competencies according to a full-level gradation: high, sufficient, intermediate, and elementary. In order to scientifically confirm the effectiveness of the implemented structural and functional model of forming STEM competences of students of professional higher education institutions in teaching mathematics, an experimental test was carried out. The total period of the study lasted 4 years, from 2019 to 2023, and was implemented in 4 stages: preparatory, ascertaining, formative, and control. To test the formation of students' STEM competences, a comparative analysis was conducted between the studied indicators using Fisher's criterion at the formative and summative stages of the study. The slide shows the results of the assessment of the levels of formation of the value motivational component. We can see that at the formative stage, the experimental group showed an increase in the sufficient and high levels. Accordingly, we evaluated each component. The slide shows the results of the assessment of the levels of formation of the creative and activity component, which showed a positive trend in the experimental group. The slide represents the results of the assessment of the levels of cognitive component formation. At the end of the experiment, there were no significant changes in the control group. Instead, in the experimental group, where the structural functional model of forming STEM competences of college students was implemented, positive dynamics were observed. The implementation of the structural and functional model for the formation of STEM competences of students of professional higher education institutions, the provision of pedagogical conditions that enhance its effectiveness, has shown an increase in the levels of critical thinking, information and communication competence, project and technological, key mathematical competence, and basic competences in the fields of science and technology. The statistical analysis of the experiment results showed a tendency towards positive changes in accordance with the defined criteria for the formation of students' STEM competences. It was possible to achieve the advantage of sufficient and high levels of students' STEM competences in mathematics. The study doesn't exhaust all aspects of the analyzed problem. Promising areas for further scientific research include the development of methodological principles for the use of immersive technologies in mathematics classes, training of STEM teachers to work in institutions of professional higher education. Thank you for your attention.